so in this lesson, we will be adding, subtracting, and multiplying polynomials, which is just kind of like a review given to you in a different format, but, you know, still it's kind of like talking about polynomials. So the first thing is, this is asking us to add this polynomial and this polynomial. So in other words, I'm taking the first polynomial, which is the 3x to the third plus 2x squared minus x minus 7. And I'm going to add that to the polynomial at the back. And you will see on your homework, they're actually already written this way. But I'm trying to give you multiple ways that you may see it. All right, now the purpose of parentheses is because you've grouped something together, right? If there's nothing outside of those parentheses that has anything to do with what's inside, then you don't need them. So what I mean is, like, if you don't have a number out front that you need to distribute, then you don't need these parentheses. Okay, or if you're not dividing all of them by one thing, you don't need the parentheses. So since I don't have anything outside that I'm going to distribute, I can take the parentheses off. And then when I look at this back here, again, there's nothing right here that I need to distribute at all. So I can take the parentheses off of that as well. Now what you're going to do is you're going to combine your like terms, and you're going to put them in order by degree. So kill two birds with one stone. If you're going to do that, start with the biggest degrees first and put those together, and then do the next biggest degree. So the biggest degree you have is 3. So I can put all my x cubes together. That's 3x cubed and 1x cubed. That would make 4x cubed. So I'm done with my x cubes. Then I'm going to look for all of the x squareds. 2x squared can be paired with negative 10x squared, and that makes negative 8x squared. Then I've got my x to the first. Well, I only have one of those, so I'm just going to drop that down. And then last, the negative 7 and the positive 8 make positive 1. And then you are done. All right, so on number 2, again, we're adding these. Now, we've already realized that we don't need the parentheses when we're adding, so I'm just going to write all of them on one line. Okay, and we're going to do the same thing. We're going to take and start with our biggest degree, which is 3, and that's the only one we have. So 9y to the third, we'll just drop that down. Then we have 3x squared and negative 5. Oh, y'all, this is supposed to be a y. I keep forgetting to change that. So if you could fix that right here, that should be a y. So 3y squared and negative 5y squared makes negative 2y squared. So I'm done there. Then we have the negative 2y and the positive 1y, which makes negative y. And then 1 and negative 4 make negative 3. On the subtraction, it says we're subtracting this polynomial from this one. So the 8x to the third needs to go first. And then you've got your minus sign, and then in parentheses, the one that you're taking away. All right. Now, if we look in front of this parenthesis, there is nothing that we need the parentheses for, right? There's nothing to distribute, so we can take those off. The second set is different, though. This one's different because I have a negative in front, right? So I need to distribute this negative. So I'm going to take negative 1 times the 2x to the third, which gives me negative 2x to the third. And negative 1 times 6x squared is negative 6x squared. And negative 1 times negative x is positive x. And then negative 1 times positive 1 is negative 1. Now we do the same that we've been doing. We go ahead and put like terms together and put them in order. So we're going to start with the cubes. So we have 8x to the third. I can put that with negative 2x to the third, which gives me 6x to the third. Then we have negative 3x squared, and I can put that with negative 6x squared to give me negative 9x squared. Negative 2x and positive 1x make negative x. And then 9 and negative 1 make 8. So really the only difference between the adding and subtracting is on subtracting you have to distribute the negative to that polynomial that you're subtracting. All right, so I've written it a different way here, but this is exactly how we wrote it on the first step up here, right? So the first set of parentheses, we don't need them because there's nothing in front. So I'm going to go ahead and remove them. But the second set, I'm going to go ahead and distribute the negative. So that would give me negative 5t cubed, positive t squared, and minus 17. Then we put our like terms together. So I start with the cubes because that's the biggest one I have. 3t cubed and negative 5t cubed make negative 2t cubed. 8t squared and 1t squared make 9t squared. I don't have any other t's, so drop that down. And then negative 4 and negative 17 make negative 21. Moving on to multiplying. So remember when you multiply two terms together, like if I take x squared times negative 2x, you multiply the outsides, right? 1 and negative 2 make negative 2. And then you add the variables on your corresponding you add the exponents on your corresponding variable. So if this is squared and this is to the first, then that would be x to the third. So just a reminder for you on that. So if I've got 3 terms here in this first one and I have 2 in the second, I need to take every single term in the first one times every single term in the second. So the easiest way to do that is just take the first term times both, the second term times both, and the third term times both. So negative x squared times a positive x will give me negative x to the third. Negative x squared times negative 3 gives me positive 3x squared. Then I'm going to move on to the second term. 2x times x is 2x squared. 2x times negative 3 is negative 6x. Then move on to your third term. 4 times x is 4x. And 4 times negative 3 is negative 12. And now you just combine like terms like you have been doing. So I only have that negative x cubed, so I'm going to drop that one down. Then I have 3x squared and 2x squared. That makes 5x squared. Negative 6x, positive 4x, that makes negative 2x. And then you've got your negative 12. So taking a look at number 6, we have 2 terms times 3 terms. So I'm going to take both terms on the front and take them times all 3 terms in the second one. So I have y times 3y squared is 3y to the third. Y times negative 2y is negative 2y to the second. Y times 2 is 2y. Then I'll focus on doing my 5. So 5 times 3y squared is 15y squared. 5 times negative 2y is negative 10y. And 5 times 2 is 10. Now I go ahead and combine my terms, put them in order. So I've got my 3y cubed, negative 2y squared, and positive 15y squared give me 13y squared. Two y and negative 10y give me negative 8y. And then you have the plus 10. Okay, when you have 3 sets, what you're going to do is you're going to focus on the first 2 and simplify those, and then take that result times the last one. So we're just going to do 2 at a time. If you try to do all 3, it just gets confusing. So I've got x times x is x squared. X times 4 is 4x. Then I'll distribute the negative 1. So negative 1 times x is negative x. And negative 1 times 4 is negative 4. Now listen to me. A lot of people want to put parentheses around this and then distribute here. You're making more work for yourself because then you have 4 things you have to distribute, correct? But this is not simplified. You have not put your like terms together. Do that first. So I've got the x squared, and I'm going to put together my 4x and my negative 1x to make 3x, and then I have the minus 4. Now, put that in parentheses so that you can multiply it times that x plus 5 that you have up top. This is kind of like doing 2 problems in one. Now you go through the whole distributing again. So x squared times x is x to the third, and x squared times 5 is 5x squared. Now I do the 3x. 3x times x is 3x squared. 3x times 5 is 15x. Then I do the negative 4. Negative 4 times x is negative 4x. And negative 4 times 5 is negative 20. Now I'll combine like terms and put it in order. So I've got the x cubed, 5x squared, and 3x squared make 8x squared. 15x and negative 4x make 11x. And then you've got your minus 20. So on number 8, we're going to focus on the first 2 and multiply those. So x times x is x squared. X times negative 1 is negative x. 2 times x is 2x. And 2 times negative 1 is negative 2. Then I'm going to put my like terms together. So the x squared goes up front. And then I have a negative 1x and a positive 2x. That's going to give me a positive x. And then I have the minus 2. Now I can take that and multiply it times the x minus 3 that was at the top. Now we will go ahead and distribute. So x squared times x is x to the third. X squared times negative 3 is negative 3x squared. Then your x times x is x squared. X times negative 3 is negative 3x. Then your 2, negative 2 times x is negative 2x. And negative 2 times negative 3 is positive 6. Now you can combine your like terms, so I'm going to drop the x to the third because there's no other x to the third. Negative 3x squared and a positive 1x squared make negative 2x squared. Negative 3x and negative 2x make negative 5x. And then there's nothing to do with your 6, so you drop that down. Now, I'm going to add a problem here just because I feel the need. So let's do 2x plus 3 squared. So the general consensus is, when I ask this question, how to work it, most people say, well, you're going to square both of them. No, 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 no. If I asked you what 4 squared is, you would be saying 4 times 4, yes? Because when I take something and I square it, I'm literally multiplying it times itself. So that means that this is 2x plus 3 times 2x plus 3. I literally need to write it out twice and then distribute, right? So if I do that, that gives me 4x squared. 2x times 3 is 6x. 3 times 2x is 6x. And 3 times 3 is 9. Then I combine like terms, which gives me 4x squared plus 12x plus 9. And we're actually going to refer back to this in just a minute after we talk about Pascal's triangle. So if you look on the last page of your notes, you have Pascal's triangle kind of put out here. This triangle has to do with binomial expansion. So like if I took a binomial, just some term plus another term, and I raised it to the 0 power, I would get 1 because anything to the 0 power is 1. If I took that same binomial and I raised it to the first power, I would just get whatever I was raising, right? So the a plus b, a plus b. If I squared it, then I would end up with this. If I cube it, then I end up with this. See how it makes a triangle, right? And the sum of the two right above always make the one in the middle. So 1 plus 1 is 2. 1 plus 2 is 3. 2 plus 1 is 3. 3 plus 1 is 4. 3 plus 3 is 6. 1 plus 3 is 4. So on and so forth, right? It makes this triangle. So here's the thing. If you're talking about maybe a shorter way to do something, really probably the main one that you're going to come across is when you take a binomial and you square it, just like we did on number 9. So if you think about test-taking strategies, for you to go through and multiply this out and then put your common factors together, if you thought about binomial expansion in Pascal's triangle, you could actually do that a lot faster. Instead of doing these 3 steps, you literally could say, I square the front, that goes in the front. I square the back, that goes in the back. And the middle is 2 times the front times the back. 2 times 2x is 4x times 3 is 12x. Bam. You're done. Okay? Now, we have talked about that when we did perfect square trinomials, right? We talked about how you get 2 of the same in the end, right? And this is a perfect square, this is a perfect square, and the middle is 2 times the square root of the front times the square root of the back. It's just the backwards of that. But that is way faster than doing this. So I put it in there just so we could talk about a test-taking strategy that you could use if you were taking a test, maybe like the ACT, where you had to square something and you wanted to move faster. So Pascal's triangle, it's kind of cool. I mean, there are tricks to all of them, but this is the most useful one, probably, in my opinion anyways.